In the previous two videos, we derived the Pythagorean trig identities and the quotient trig identities. And now in this video, I want to derive the reciprocal identities. So here's a typical trig identities sheet. You see the Pythagorean identities here. Here are the quotient identities. They're calling these the tangent and cotangent identities, but I think more officially these are called the quotient identities. And then here are the reciprocal identities. So you know sine theta is 1 over cosecant theta, cosine theta is 1 over secant theta, etc. Now, progressing through the textbook, the reciprocal identities were actually the first trig identities derived. And I kind of skipped over these as, just looking at them as official trig identities because it seemed kind of trivial. I almost decided to not to even make this video here. But technically, these are trig identities. And so quickly, let's just take a look at how they're derived, if you want to call it derived, from an official standpoint. So we start from the general definition of the trig functions. Okay, so let's go through this general definition again. You have an xy coordinate plane. Here's positive x, here's positive y. And you have an angle that you want to evaluate the trig functions for, right? Trig functions, the input to trig functions are an angle. So you've got some angle, and this angle is drawn from standard position. Standard position is you have an initial side that's directed along the positive x-axis. So you can think of like a ray whose endpoint is fixed at the origin, and then it's directed along the positive x-axis, and then the angle is measured, that the positive direction of the angle is counterclockwise. But you can also have negative angles, but positive is counterclockwise. And once you have an angle, what you can think about is, based on that angle, you could draw another ray that represents the terminal side, whose tail is also fixed at the origin. And so, based on theta, the direction of the ray is constrained. But the length of the ray can be any length, at least starting at the origin. But the direction of the ray is fixed based on theta. Okay? Now, all this applies for any angle theta in any quadrant, but what you do is you pick a point along the ray other than the origin. Any point, it doesn't matter. The distance from that point to the origin is called the radius r. And then you make a right triangle where you from that point you extend a line to the horizontal axis that's perpendicular to the horizontal axis. Again, you do this. This is the same method for any quadrant, an angle in any quadrant. And so then you form a right triangle with side lengths based on the coordinates of the point you picked. But those side lengths could be negative. Like here, both x and y would be negative, depending on the coordinate directions. But the r is always positive, and the r you find with the Pythagorean theorem. X squared plus y squared is equal to r squared. Okay, so with that, you can make this setup for any angle, right? Any angle. You can do the same setup, no matter what quadrant the angle's in. And again, it's not like we've deviated from the general properties of the Cartesian coordinate system where we're honoring positive and negative x and positive and negative y. Okay, and so with that, these are the trig function definitions. Sine theta is y over r, but r is always positive, but x or y could be negative. So here are the trig functions, their definitions. Okay, so what are the reciprocal identities? Well, what you can think about is, imagine we define these trig functions. So we've just finished defining the trig functions, and we notice that, well, look, cosecant theta is just sine theta flipped. Secant theta is just cosine theta flipped. Cotangent theta is just tangent theta flipped. So the reciprocal identities is that sine theta is the reciprocal of cosecant theta. But you can also write it the other way and say that cosecant theta is the reciprocal of sine theta. Okay? we see that cosine theta is the reciprocal of secant theta. And also secant theta is the reciprocal of cosine theta. Okay. Tangent theta is the reciprocal of cotangent theta. And cotangent theta is the reciprocal of tangent theta. And there you go. That's the 6 reciprocal trig identities. Now, just note, though, that at certain quadrantal angles, you could have certain trig functions that are undefined. And so these identities, like all of the trig identities, are only valid if you're not dividing by 0 after you input the theta.